Well, hello there, everyone. This is KP the Math G. I'm sporting this. I don't know if you can see it or not. I'm sporting this hat here. This is the hat that I bought on my wife and I's honeymoon. So anyway, I was sporting this one the last time, and I know I'm gonna get on math. Believe me. Okay, so I was sporting this one, and I asked my wife, "What do you think?" And well, needless to say, she suggested that I wear this one instead. This is my fishing and farming hat. This is my, well, just go out and enjoy the town hat. Okay, I'm not here to sport hats or to advertise them. I'm just here to do some math. We are talking about a derivative of y equals a to the x power, or y is equal to a logarithm. Okay, a common logarithm at that. We know that we have derivatives of natural logarithms of ln, but we want to look at the derivative of a common logarithm. I don't know how much of this is on that test, but suffice it to say we are going to go over it. I want to kind of look at the derivation of this one here, starting with this, and then I want to do an example with the derivative of this, and hopefully if I have time we'll do this one. I don't know how much time it'll take to do all this, but let's go ahead and get started. Okay, find the derivative, and I'm just going to derive this. I'm going to start by saying, well, okay, we can, this x here is up here, and ln can kind of knock that down. Let's see if you can follow what I'm saying. I'm going to take the ln of both sides. And there we go. Alright. And I want to rewrite this. Now remember that there is a rule that says that if the exponent is here, we can just move it to the front. So ln y is equal to x times ln of a. Now a is a number, okay? It has to be greater than 0. Because ln does not take anything less than, not even 0. It can't be greater than or equal to 0, it's got to be greater than 0. Okay, so this is just a number here. Likely an irrational number, okay? Okay, so just keep in mind that this is a number. This is a variable, this is a variable. So now let's take the derivative. From our last study, we found that the derivative of ln is 1 over that thing times now dy over dx. That's the left side of the equation. Alright, now this side is just the derivative of x is just 1 times ln of a, and that's it. That's all you do. Well, we can solve this easily. Matter of fact, this is just 1 times ln a is just ln a. Okay, so that's what we're going to do there. We can multiply by the reciprocal of y, multiply by y on both sides. So y and y. Okay, that divides out. And we have dy over dx, which is what we're looking for, now is equal to y ln a. We don't want to leave it like that. We want to go ahead and substitute in place of what we started off with. So y is a to the x. So then we have dy over dx is equal to a to the x ln a and ln a, okay, and then of course times whatever the derivative of x is, x prime. Alright, so I want to throw an example out there to you. Okay, let's find a derivative of something here. Alright, we can use the same procedure, or if you can just memorize this, and yes, that's right, that is correct. Okay, alright. Okay, if we can memorize a to the x times ln of a, then we don't have to do all this each time. But and if you forget this, you can always introduce ln on both sides, put the x in front, whatever that is in front, and go from there. You can do that. Okay? And of course you'll get the exact same answer because we just derived this. If you're clever enough to, well, I say clever enough, sometimes I'm not clever enough. If you think about this and you have this in your mind and you have this memorized, it is so much quicker, it is so much easier. So let's pick a problem. Okay. Alright, so let's say we have y is equal to 2x over 4. Alright, so we don't have, and I could have very easily said cosine x for all that matters. Well, let's just leave it like that now. We know then that we want to take the derivative of this, so now dy over dx. If we commit this to memory, it's a to the x, whatever x is, right? This is it, x. Just recopy this, that's all you got to do. Now ln of 2, that's it, that's your a is 2, so a is 2. Alright, so ln of 2. Now let's take the derivative of x over 4. We're going to take that derivative, which, by the way, get where you just get used to saying 1/4 x. Now you can do x over 4. 1/4 x is the same thing. Okay, so because you have 1 in the numerator like this. Okay, it's 1/4. Okay, so there it is. Alright, so let's take the derivative of that. Alright, so dy over dx is equal to 2x over 4 ln 2 times the derivative of 1/4 times x is just 1/4. Okay, and if we want to, we can put this out in front. So 1/4 times 2x over 4 ln 2, or if you want to write it down this way, you can say it is 1, no, I'm sorry, it is 2 to the x over 4 ln 2 all over 4. Now, do not make a mistake here and divide this by 2 and divide this by 2. ln 2 is a number, okay? It is not 2. If it's 2 over 4, we can do that. But ln 2 is not the same as 2, and we know that, don't we? And this 2 raised to some power, it's to some power, so we cannot do anything to this either. Okay? So, oh yeah, you can make it 2 squared and do something there, but we're just going to leave it like that. Okay? Alright, that's how you do it. Just simply plug it in, 2x over 2 to the x over 4 ln of a, which is 2, and then the derivative of whatever's up here. Okay, Alright, so that is that. Okay. I mean, they come in all forms and shapes and all kinds of other things. We could have a number in front of this, or a lot of times, I mean, we can leave a 2 here, and a is still equal to 2. We can even put a cosine x if we want to. Alright? And there again, we could very easily just do that. So again, alright, so dy over dx. Alright, so is it a to the, it's just that. Just copy it down. There we go. Alright. Now, ln of a is 2 again. Now the derivative of cosine, alright, so cosine x, we want that derivative of that. That stands for derivative. Okay, so let's see, that's equal to 2 cosine x, ln 2. Derivative of cosine is negative sine, and that's it. The derivative of x is 1, so we don't need to worry about that. So we can just rewrite this as negative sine x times 2 cosine x, or you can put ln 2 in that order. It doesn't matter. Times ln 2. Alright, there it is. Now, that's pretty straightforward, I think. If you can just memorize, just write it down first. Take ln of 2 and then the derivative of whatever is up here. So 1, 2, 3. That's it. Okay, 1, 2, 3. Alright, let's flip the board over. Okay, let's flip the board over. And this time we want to, well, you don't have to be 63 to stumble, you know. Okay. Alright. Bad humor. Okay, I get it. Now, let's look at this. Y is equal to log base b x. Alright. It's kind of similar to a to the x, but it's kind of easy to do. Maybe we want to do, let's rewrite this where we put this on the left side and y on the right side. There's a reason behind that. Okay, a little story here. B is tired of being the base underneath here, and you know it doesn't know what to do, so it's saying, look, I'm tired of being here, and the log is saying, well, go over here and talk to y and let y decide if there's anything y can do for you. So he goes over here and he says, okay, y, I was tired of being crawled under this log. What can I do? Well, y says, if you exalt me, I'll let you come to my side. So in other words, b exalts y. And then of course when b comes apart, the log just kind of drifts away and all we're left with is x. Okay. You probably already know that anyway. Alright, so, but anyway, this is it. Now, look what we can do, just like we did a while ago on the last example. We can introduce ln, can't we? Well, let's do that. ln x is equal to ln b to the y power. Alright, and then of course we need to put that y over here. So ln of x is equal to y times ln of b. Keep in mind, b is a number, okay? Alright, and by the way, b has to be greater than 0 because it's ln of b. Alright, so yeah. I have to look that up again because I'm not so sure. Yeah, I think that is correct. Alright, so now let's take a look at this. I want to take the derivative of this side. Alright, well that's just simply 1 over x. Okay. The derivative of x is 1, so that's just 1 over x. The derivative of y is 1, but that's 1 is actually 1 times dy over dx. Might as well, when you remember when we do this implicitly, we have to, tack on dy over dx. So the derivative of y is 1, so 1 times dy over dx is just dy over dx. And of course now, times ln of b. Okay? Alright, so let's write this the other way around. So dy over dx times ln of b is equal to 1 over x. Okay. I'm thinking I got everything right. Yep. That looks good so far. Yeah, that looks good. Okay. Just wanting to make sure. Alright, now I just need to solve for dy over dx. So I'm simply going to multiply, or I can divide by ln b. So if I divide this side by ln b, I'm going to divide this side by ln b, and there it is. Move the 1 over a little bit, and there it is. So here it is, dy over dx. Notice this divides out. Is equal to 1 over, x ln b. Alright. And that's it. And again, this is for all. That means for all x greater than 0. For every x. That means for every. Okay. Alright, so there it is. Look at that. That's what we're going to write up here. So let's see, then dy over dx, we'll just write it up here, is equal to 1 over x, 1 over x, ln of b. Well, let's look at a problem then. Okay. Okay, let's just erase all of this. Bear with me. I know, erasing takes time. Alright. I apologize. This is all I've got. I've got a whiteboard and markers, and I'm thankful to have that. So, okay. One thing you learn in life is be thankful for what you have. Don't worry about what you don't have at the time. Alright, so here we go. Let's look at this. Let's say we got y is equal to log base 6, 3x plus 2. I'm going to rewrite this. Oh, no, I'm not. Now look, b, in this case, b is equal to 6. So I'm just going to kind of go by the formula here. Actually, if you wanted to, you could say 1 over x times 1 over ln of b. Okay, it's the same idea. Alright, so what we have here, dy over dx. That side is dy over dx. Okay. Alright, so this is 1 over x. Well, all of this is x. Okay. So 3x plus 2 times, alright, 1 over 6. And of course we got to remember to take the derivative of 3x plus 2. We got to take that derivative. And maybe I should have added on that times x prime. Okay. Let's make this numerator x prime. Okay, there we go. Alright, so let's see what we got here. This part here is the only thing that needs to be done. If you want to, we can say, well, that equals to 6, 1 over 6 times 3x plus 2. And the derivative of 3x plus 2 is just 3, because remember, derivative of constant is 0. Just have a number with x, that's just that number. So that's just 3 here. And if we rewrite it, we got 3 over 6 times 3x plus 2. And of course we can divide out. 3 goes into 3 one time, 3 goes into 6 two times. So that's equal to 1 over 2 times 3x plus 2. And that's it. Okay. Wait a minute. Did I leave something out? Whoa. Big time. I did. Ah. Oh boy. Ha ha ha. Okay. This is unfortunately incorrect. Unfortunately, I had to say that, didn't I? Yikes. Well, when all else fails, erase. I had a professor tell me a long time ago to erase everything. And, wow. I knew something didn't look right because I didn't have an ln anywhere. I need to have an ln in my formula. Okay, well, let's do it again. Okay, so let's see. It is 1 over x, which is, by the way, 3x plus 2 times 1 over ln of 6. That's the only thing I left off. Times the derivative of 3x plus 2, which we already found to be 3. Okay, well, if you want to, we can still do that. Okay, now equals, alright, so 1 over 3x plus 2 times 1 over ln of 6 times 3 over 1. Okay, all this is simple now. 3. Alright, 3x plus 2. Alright, ln 6. Sometimes I feel like Charlie Brown and Lucy telling Charlie Brown, good grief. Well, at least I caught my error, right? And that's really what counts. You know, you look up here and you say, well, there needs to be an ln right here. Okay, I apologize for that, but we did correct it, didn't we? Boy. Again, I don't feel like that has anything to do with being 63. A 32-year-old can do that. An 18-year-old can do that. Just simply just leave off the ln part and distribute that 6, or cancel the 3 and the 6 and make that 1 over 2 and blah blah blah. Okay, there it is though. Alright. And we know that x has to be a positive. 3x plus 2 has to be greater than 0. Okay. Okay. Thank you so much for being patient with me on this. And again, this one could have been anything that we wanted it to be that had an X in it, but this is sufficient enough. So just kind of get the idea. Let me erase this one more time. I do apologize for the mistake, but there again, sometimes even KP the Math G makes a mistake. The good news is I caught it, and the good news is, had I not caught it, I would have addressed it in my next lesson, because I watch all of my videos. Okay, now, just by quick review, if we have y is equal to a to the x, then dy over dx is simply a to the x times ln a times the derivative of x, whatever that is. Alright, so that is that. If we have y is equal to log base bx, we can rewrite it as an exponential, and we have, well, if we want to take this derivative here, then all we got to do is just say dy over dx. Now, here we go. It is 1 over x ln b times the derivative of x. So that's the two very similar ways in solving. And there again, if you wanted to if you wanted to rewrite this as, for example, b to the y is equal to x, you could certainly introduce ln b to the y is equal to ln of x like we did before, and then y ln b equals ln of x, and then take that derivative there. If you wanted to, you can do that to any problem. It's just the long way around. You can do that. Over the river, through the woods to grandmother's house. Okay? Yeah, it is getting close to Thanksgiving, isn't it? Okay. Alright, so anyway. This one here, the same way. We could say ln of y is equal to ln a to the x. So ln of y is equal to x ln of a. And then take the derivative of both sides. Alright. I hope this has helped you. I trust that that you can see that no matter what mistakes I make, I will do all I can to correct it and make sure you're doing everything good. And so I do apologize for that. But needless to say, we did correct the problem, and we got everything correct here. Just know that you do have a pattern here. If you can just somehow, some way memorize. I'm just going to erase this part so you can see what you got here. Okay. If you can somehow memorize these two right here. This one is this, and this one is this here. And if you can kind of memorize that, you've got it made. Okay. If not, you can always introduce ln and look at the pattern that I showed you on both of these. Okay, once again, this is KP the Math G signing off. Have a really great day today. Oh, by the way, that is my signature dismissal. Okay, like that. Okay.